In this lesson, we're going to work on solving a system of three equations with three different variables. And let's start with the first system. So the first system has, as you can see, three different equations. I'm going to call them equation 1, equation 2, and equation 3. Now, sometimes the system is pretty simple if you take a closer look at it. Now, if you look at the third equation, you can see that there's a single variable. I have one equation with one variable, which is x. I can solve for x. Now, if you look at the second equation, I have an equation with two variables, x and y. If you look at the first equation, I have an equation with three different variables, x, y, z. So let's start with a simple one, which is 2x equals 18. So let me copy that to my first step, and let me get rid of these. I'm gonna again call this 1, call this 2, and call this 3. I'm gonna take the first equation, which is 2x equals 18, and I'm going to copy it to the first step, and I'm going to solve for x. Now if I divide both sides by 2, I get x equals 9, and I just found the first variable. Now let's look at the second equation, which is negative 3x minus 14y equals 1. Let's copy that down with a different color, and let's see what we can do. So minus 3x minus 14y equals 1. Now what if I plug in the value for x? Then I will end up with an equation with only one variable, which is y. So negative 3 times 9 is a negative 27. Minus 14y equals 1. To solve for y, I need to add 27 to both sides. So in this case, negative 14y is equal to 28. Now I can divide both sides by negative 14, and I will get y to be equal to negative 2. I just found two variables. Now what if I plug these two variables in the first equation? The first equation, I have x, y, z. I know x. I know y, then my only unknown is z. So let's copy this in step 2. And let's plug in x and y in this equation. So it's 11x plus 13y minus 8z equals 17. I just found x to be 9, so let's plug it in. I just found y to be negative 2, so also let's plug it in. Negative 8z equals 17. 11 times 9 is a 99. 13 times negative 2, that's in negative 26. Minus 8z equals 17. Let's combine 99 minus 26, and that's going to be a 73. Minus 8z equals 17. Now to isolate the z, I need to subtract negative 73 from both sides. So negative 8z is equal to 17 minus 73, which is a negative 56. Now if you divide both sides by a negative 8, you can solve for z. So z in this case is 7. So there you go. I just found my third variable. So in step 3, let's write down the solution. So my solution is going to be 9, negative 2, and 7. Don't forget, always check your solution by plugging in your values in all three equations. So let's go ahead and try that. I'm going to try in the first one. So 11x plus 13y minus 8z equals 17. So 11 times 9, that's a 99. Plus 13 times negative 2, that's a negative 26. Minus 8 times 7, that's a negative 56. And if you try to add 99 and negative 26 and negative 56, you will get 17, so that is correct. Now go ahead and plug your values also in the second equation. Negative 3x minus 14y equals 1. So negative 3 times 9 minus 14 times negative 2. And check, is this going to give you 1? And the answer is correct, yes. Because negative 3 times 9 is a negative 27. Plus 28, because negative times negative is a positive, and that's going to give me 1. Now let's go ahead and check in the third equation. So I just found x to be 9. So 2 times 9 is 18. So yes, it is correct. So remember, always double check your solution by plugging it in. Now let's go ahead and look at our second equation, second system. Okay, let me turn this. Okay. So the first one is going to be my first equation, second equation, and third equation. Always, guys, before you start eliminating or before you start adding and subtracting or multiplying, take a close look at your system. Is there a way, a simple way to solve this? Now, if you look at the first equation and the second equation, x and negative x, that can cancel out. Negative 2y and plus 2y, that can cancel out. Then I will end up with just a z, and I can solve for z. Now also take another look. Look at the second and the third equation. If I add them, negative x and x can cancel out. 3z and negative 3z can cancel out, so I will end up with only y. So let's try that. Let's add equation 1 and 2. That can be my first step. And then let's add equation 2 and 3. If I add equation 1 and 2, the x and the y will cancel out. I will be left with z, so I can find z from adding 1 and 2. If I add equation 2 and 3, the x and the z will cancel out, so I will be able to find y. And then once I find y and z, I can plug in any of the original equations to find x. So let's go ahead and start working on that. So let me delete this. Okay, let's copy the first two equations to step 1. So in step 1, let's write the first equation, which is x minus 2, y plus z equals negative 2. And let's copy the second equation, which is negative x plus 2y plus 3z equals to negative 2 as well. And let's add these two equations. X and negative x can cancel out. Negative 2y plus 2y will cancel out. 1z plus 3z, that's a 4z. And negative 2 plus negative 2, that's a negative 4. There you go. I have now a simple equation with only one variable z. If I divide both sides by 4, I'll be able to find z, which is in this case negative 1. So I just found the first variable. Now let's go ahead and copy the second and the third equation into step 2 to be able to find my second variable. So negative x plus 2y plus 3z equals negative 2. And the third equation, which is x minus 3y minus 3z equals to 0. Let's try to add these two equations and see what I can find. Negative x and x can cancel out. Plus 3z minus 3z will cancel out. 2y plus negative 3y, that's a negative y. And negative 2 plus 0, that's a negative 2. I need y, I don't need negative y, so divide by a negative. A negative and a negative will become positive. So y is equal to 2. I just found my second variable y. Now take any of the equations, original equations. I'm going to take the first original equation, and I'm going to plug in the values for y and z. So I just found y to be 2. I'm going to plug it in. And I just found z to be negative 1. I'm going to also plug it in. Now x minus 2 times 2, that's a negative 4, plus negative 1, so that's a minus 1, equals negative 2. X minus 4 minus 1, or negative 4, negative 1, that's a negative 5. Now to find x, you need to add 5 to both sides. So in this case, x is equal to 3. So your solution is going to be x, which is 3, and then y, which is 2, and then z, which is negative 1. Now let's move on to our next, most likely a pre-AP question. So let's take a closer look at our third system. So I'm going to call the first equation to be equation 1, and then equation 2, and then equation 3. Now, let's take a closer look at this system. Do I have an equation with a single variable where I can actually solve for that variable? No, I don't have that. If I add two equations, will any of the variables cancel out? I also don't see that. So probably I need to multiply by a certain number to cancel one of the variables. And now your first step is to choose what variable to eliminate. So let's see, which one is easier to eliminate? Let's take a closer look at the x. If I multiply this equation by a negative and add it to the third, then negative 2x plus 2x will cancel out. That's simple. Now if I look at the first equation, if I multiply it by a negative 2 and then I add it to either the second or the third, negative 2x and 2x will cancel out. So that's simple too. Now let's look at the y's. I have a 2, 1, and 3, so probably I need to multiply more than once. 1, 3, negative 5, so also I need to multiply. So I think x is the easier variable to eliminate. It's the easiest one. Now remember, there's more than one method to solve a system of 3 equations, and you can choose any method. Just try to choose the one that's simpler to you. So let's copy the first and the second equation onto step 1, and let's try to eliminate x. So let's do that. So my first equation is going to be x plus 2y plus z equals 10. And let me multiply this by a negative 2. So remember, you have to multiply every part of this equation by negative 2. So it will be negative 2x, negative 4y, negative 2z equals negative 20. And now let's copy the second equation, which is 2x minus y plus 3z equals negative 5. Now let's add these two equations. Negative 2x plus 2x cancel out. Negative 4y minus y, that's a negative 5y. Negative 2z plus 3z, that's a plus 1z. And negative 20 minus 5 is negative 25. So that is the first equation that I got by eliminating variable x. I'm going to call it equation 4 so I don't get confused. Now let's go ahead and copy the second and the third equation. So 2x minus y plus 3z equals negative 5, and 2x minus 3y minus 5z equals 27. Now keep in mind that you always need to eliminate the same variable. So if you combine two equations and eliminated x, you need to combine another two equations and eliminate the same variable. So in this case also x, because you want to end up with a system of two equations with two variables, and you want them to be the same variables. Now let's go ahead and multiply the second equation by a negative 1. So I will get negative 2x plus 3y plus 5z, so as you can see the negative changes the sign, equals negative 27. And let's copy this equation and let's add them. So 2x and negative 2x cancel out. 3y minus y, that's a 2y. 5y plus 5z plus 3z, that's an 8z. And negative 27 minus 5 is negative 32. So that's going to be my second equation with two variables. So I'm going to call it equation number 5. So there you go. This has y and z, and this has y and z. So I'm on the right track. Now let's review what we did. So every single time you have 3 different equations, you need to combine 2 of them. So I combined 1 and 2, then I combined 2 and 3. You can choose to combine 1 and 3. It doesn't matter, as long as you decide to eliminate the same variable. In this case, I chose to eliminate x. You can choose to eliminate y, you can choose to eliminate z. It doesn't matter, you will end up with the same equation. But remember, every time you combine 2 equations, try to eliminate, or you must eliminate the same variable. So now, in step 2, I ended up with 2 equations, which are negative 5y plus z equals negative 25. And the second equation is going to be 2y plus 8z equals negative 32. Now this is something that you are familiar with. You know how to solve this. It's a system of two equations. Now I know that this lesson says elimination, but I'm going to allow you to use any method that you find easier. For example, if you saw that there's a single variable and you want to use substitution to solve that, go ahead. Since you already used elimination in the first step, it's fine for you to use another method. So you can combine methods in a system of three equations. So let's solve for z in the first equation by adding 5y to both sides. So I end up having z equals 5y minus 25. Since I have a single variable, it was easier to do substitution. Now let's plug in z in the second equation. And let's try to solve for y. So 2y plus 8 times 5 is a 40y. 8 times negative 25, that's a 200. Negative 200 equals negative 32. Now 2y plus 4y, that's a 42y. So if you add these two, you get 42y. Now add 200 to both sides. So you get 42y is equal to 168. Now you need to find y, so divide both sides by 42. So you get y to be equal to 4. Now once you find y equals 4, you can now plug it back in the equation over here, and you can find z. So 5 times 4 is a 20, minus 25, that's going to give you a negative 5, and that's the value for z. Now in step 3, you just found two variables out of 3, so you can plug it back into any of the equations. I'm going to use the first one, and then you can find the third variable. So I just found y to be 4, I'm going to plug it in. I just found z to be negative 5, I'm also going to plug it in, and I'm going to find x. 2 times 4 is an 8, minus 5 is equal to 10. 8 minus 5, that's going to be 3, so x plus 3 equals 10. I'm going to subtract 3 from both sides to get x, so x is equal to 7. So just found all three variables. So the solution in this case is 7, 4, and negative 5. Remember, plug it in all three original equations to check your solution. Okay, so remember, let's review what the steps are. So every time you try to find a solution for a system of three equations, you need to combine two equations at a time. So you can combine equation 1 and 2. I had to multiply the top equation by a negative 2 because negative 2x and 2x, that would go away. And I will end up with an equation with two variables, y and z. And then I chose to combine the second and the third equation. So I multiplied one of them by a negative, so x would cancel out. And then I also ended up with a second equation with two variables, y and z. Then I had a system of two equations, y and z, which I know how to solve, either substitution or elimination. I found y and z. After I did that, in step 3, I plugged it in the first equation to get x. Remember, your last step is always to check your solution. Now I hope that this lesson was helpful. Make sure that you do the practice sheet to have more practice.